Okay, so now let's talk a little bit about network topologies. There are some basic network topologies we can review here. The very first one is called point-to-point. The very first one is called point-to-point. As the name suggests, this topology simply means connecting two hosts using a direct line. So this is, I would say, the simplest topology out there. So if I draw the topology, it will look like this. So you have this host 1, another host 2, just connect the two, and that is point to point. So one of the simplest topology out there. By the way, I didn't really define what a topology is, so let me just briefly do that before we move on. Network topology means basically describing how network devices put together to form a network. So this is a physical layer concept, meaning in the topology you see the wires, you see the devices and how they're connected. So that's why we say this is a physical layer concept. So the next topology I want to look into is the topology called star. And this topology kind of builds on top of the point-to-point topology. In this case, you have a network device called a switch at the center, and all the other devices are connected to that central device. So network devices connected to a switch. That's called a star topology. And one thing you note here is that the traffic goes through the switch all the time. So if I want to send something from one device to the other, the traffic has to always go through the switch at the center, which is at the center of the star. So if I draw the topology, it will look like this again. So let me just do this again. So you have this switch in the middle in the star topology, and you have all these network devices. So host 1, host 2, host 3, host 4, host 5, right? So this looks like a star, and that's why it's called a star topology. And one thing I want to add there is, again, there is only one path from one device to the other in the star topology. Let me move this, see if I can move this whole thing here. Okay, I'm going back to the diagram again. As you can see in the diagram, in color, yeah, let me choose the pen. I mean, from host 1 to host 3, for example, you go to the switch and you go to the host 3 directly. And one more thing I want to mention here is the packet goes to only its destination. It doesn't go to anybody else. So this is not really broadcasting the packets. It sends one packet directly to its destination. That's another thing to remember in terms of the star topology. Okay, so the next one is, we have next topology, which is extended star topology. Extended star topology. So in this topology, basically you're putting multiple star topologies together. So this is basically a collection of multiple star topology put together. But since this is just a collection of the star topologies, you still have only a single path between the two devices. It has a hierarchy of the switches like this. Let me show you. So that's one switch, right? Switch 1, and it has its own devices connected, but this switch might have another switch connected to it, right? Switch 2, and it has its own devices and so on. But again, this switch might have another switch connected to it and so on. So that's what we mean by the extended star topology. Next one is this thing called bus topology. Oh, before bus topology, let's talk about mesh topology. So as you can see, the topology is mainly used for the switches, and the switches are only needed in a single network, and it makes sense because the potential for the failure in a single network is pretty low. So when you have only a single path between the hosts, I mean, you can quickly recover from a failure if you are talking about a single network and you have full control over it. So it's not a big issue. But if you're talking about these individual networks connected together, if you're talking about the situation of an internet, a network of networks, I mean, many things can go wrong and many things are really out of your control. So in that case, it's nice to have some redundancy, and that's why we need this thing called mesh topology. So instead of having a single connection between the devices in the mesh topologies, we have multiple connections. So the biggest thing about the mesh topology is basically multiple connections between hosts or network devices. So if I just draw the topology, it will look like this. So you have network devices like routers. So router, let's say this is 1, okay, router 2, router 3, router 4, and so on. You don't want to have only single connections between the routers, because if something goes wrong, there's no way you can get to the router. So to give an example, let's say this connection failed. In this topology right now, there's no way you can get to router 3 because there was only one connection. However, if you had these other connections like this, even if this connection fails, you can still go to router 4 and then eventually go back to router 3. So this redundancy is critical in an internet which consists of these multiple routers. So the mesh topology is really the one used for the internet, and the devices really using the mesh topology are the routers. And the final one now is, so the final topology is something called bus topology. Okay, so bus topology. And bus topology is basically the topology that uses broadcasting. And broadcasting here means you're sending everything to everybody. And this sounds kind of familiar to you because this is what happens in wireless networks. So either wireless LAN or LAN or WAN, that's when this topology is used. Another thing to note here is that there was a device that was used in a wired network that used this topology. It's called hub. Hub uses this topology too, but broadcasting isn't very efficient in a wired network communication. That is why the hubs are not used anymore. Switches kind of replaced the hubs. So we no longer use hubs, but still in the wireless LAN or WANs, this bus topology is being used today. So there is this little danger in wireless networks. Your traffic might be picked up by somebody else. So this is pretty much all the topologies, all the basic topologies we are going to talk about in this class. And in reality, all these topologies are somehow present together in a realistic everyday network situation. Thanks for listening.